Welcome back to LeetCode Path to Pro. Today is Saturday, September 30th. I'm going to keep doing kind of the format I was doing, where I just kind of sit here and do it for a while. Yeah, I had a pretty late last night, so I'm pretty tired. But yeah, so I think we did these four yesterday. Let's try to do FizzBuzz, and then we'll be on to some mediums. And these are all, I think these are all DP, or these first two at least. Then this is like BFS, interesting stuff. It's actually an interesting problem. And then this is DP. This is like OG DP problem. And then this is these. Oh, and I've done these. These three are all very interesting and kind of go along with each other. And I bet this one too. That'll be a fun one to try. But yeah, so now we're on FizzBuzz. So like I said, I've done this one recently, so let's hope I can remember how to do it. It says super high. Who have done it? Okay, so 412 FizzBuzz. It's easy. Turn on some music. That's not what I want. A lot of tabs. Where is it? Is it this one? Oh, it is. But yeah. Oh, it's so loud. Where is it? Yeah. So FizzBuzz. So we're given an integer n. We want to return a string array answer, one indexed, where answer of I equals FizzBuzz if I is 3 and 5. Answer of I equals fizz if I is 3. Answer equals I equals buzz if I is 5. Okay, so let's do the second one. So we're given n equals 5. And we're going to want an answer array. Right. Yeah, seems pretty straightforward. And then we could have like a variable, sum, or we'll just call it val. This is the current val. Would we even need that? We could just use I, right? We're using I. So if we just loop through for I, and it's one indexed. So what that means is normally when you have an array, right, like that has like a 1, a 1, a 3, and a 5, let's say. Normally arrays are 0 indexed, meaning the first value is at the 0th index, second value is at the first index, so on. So it's just kind of like, normally we'd count like 1, 2, 3, 4, but for whatever reason, count by 0, 1, 2, 3. But in this case, they want it one indexed, so that's the first index. Yeah, so we could just do that by saying for I in range, we start at 1. So we start at the first index, right? Because ultimately what we're looking for is the, basically, as you can see here, it's kind of counting up. So the first value in the array is going to be 1, the second value is 2. So that, like, they're just saying, take the index value, but disregard the first index value. So just start at 1, as if the first index, as if 1 was the first index value. 1 was the 0th index value. So that's what we're going to do. We're going to start counting at 1. We're going to go 1 past n plus 1, or 1 past n, so that's what we're doing, n plus 1. Then we're going to say if I could be modulus divided by I wonder if we can just do it without that. It's a little loud. I wonder if we can do it like this. So answer, and then we just want to append answer. And if it's divisible by 3, what do we want? Fizz. Else if I is divisible by 5, we want to append buzz. Else if so then we append fizzbuzz, and so that's only going to happen at multiples of 15. Else we just want to and we got to make it a string, right? Return answer. So we can't do it like that. So I guess we have to do, because technically that makes sense. Because right, anything can be divided by, or modulus divided by 3. So basically, we're checking: is there a remainder after we divide by 3 or 5? Is what the modulus is doing. So it'll work here. I guess we want to put this first. So this is just an order problem. We could probably add some additional checks to fix it, but this will be easiest. Buzz here. Fizz. So that way, checks that first. And then, so that should work. Yeah. Okay. I don't know why the memory. How could you improve the memory here? Yeah, I feel like the memory should be fine. Sorry, a little note. Right. So basically, yeah, we're Time complexity here should be just O of n. Space complexity is technically O of n, but we're supposed to use that answer array to return, so I'd say just O of 1 basically. I don't know if you could improve that. I bet this answer got like really fast. Speed, 81. So I mean, maybe you could do it a little bit faster, but I don't know if you could do it any faster than O of n. Yeah. Okay, cool. Cool. Easy one today. Good warm up. Made me feel good. Let's see. On to the next. What are we looking at now? Predict the winner, 486. So this one I remember was pretty tricky. And the solution that I kind of read about and watched is like not intuitive. Yeah. So we'll see if we can figure it out. So this is a DP problem. And I found the bottom. The solution that made more sense to me, I don't even know if it made more sense to me, but the solution that I found that like was well documented and so I was able to understand it was a bottom-up solution. And it's also very clean code, so I liked it. Yeah. Oh gosh, sorry. Yeah, so basically this is a game problem. I think is a term they used. Excuse me. So we're gonna if an integer array nums. Two players are playing a game with this array. Player 1, player 2. Player 1 and player 2 take turns, with player 1 starting first. Both players start the game with a score of 0. At each turn, the player takes one of the numbers from either end of the array. So num0 or nums, -1 basically, which reduces the size of the array by 1. Player adds the chosen number to their score. The game ends when there are no more elements in the array. Return true if player 1 can win the game. If scores of both players are equal, the player 1 is still the winner, and you should also return true. So that's an important fact. You may assume that both players are playing optimally. Okay. So if we look at an example like this, an example here, let's see this example. So player 1 goes first. Player 1 can pick 1 or 7, right? Yeah. Player 1 can pick 1 or 7. So let's say they pick 7. So that means player 2 can pick 233 or 1. Obviously player 2 is going to pick 233 because they're trying to maximize their score. Then player 1 can pick 1 or 5. Probably going to pick 5. So player 2 gets stuck with 1. But player 2, obviously, they got 233, much larger than anything else. They're going to win. So let's see, if player 1 is playing optimally, they're going to want to pick. And it would be really tough to design something that could like see ahead, and pick ahead almost. So that's why DP, I guess, is this kind of, we want to use a little bit of backtracking almost. Where like we start going down a path. Well, we don't even want to do backtracking, we just want to see all the paths. But right, so player 1, they tried picking 7 last time, didn't work out for them. So they pick 1 first. Player 2 can pick 7 or 5. They probably want to pick 7, but I mean, it doesn't really matter what they pick, right? Because either picking either of these is going to reveal the 233. So player 2 is going to want to pick, they'll pick 7. It's bigger, it doesn't really matter. And then player 1 obviously is going to pick 233. Player 2 is going to pick 5. yeah, so we're going to use DP to do this, bottom-up solution. So first we need to get our DP array set up. So we take 0, multiply it by the length of nubs, our DP array. Oh man. So that means DP turn that up a little bit. This is our DP array. And we're going to use this example. And I'm going to look at my notes for this problem. Shit, man, it's hard to get some fucking room. So write DP will just be zeros to start. How cute they are. Those zeros. Yeah. This is O at squares. Backwards. I mean, it's bottom up, so you want to go through backwards. So basically, our goal is we want to fill this DP array, right? And what we're trying to maximize is we're trying to maximize the difference player 1 can have over player 2, or just the difference in scores, right? Because that's playing optimally. That's what player 1 wants to have, right? They want to have the greatest difference. Obviously, like they could win. They probably don't care how much they win by, as long as they win. But in terms of the math, like playing optimally would mean creating the greatest difference between their score and the other player's score. So you want to loop through nubs backwards. I think do we just want to loop through nubs? Oh, it's a list. It's not. And we want to set DP of I equal to nums of I. Right, so, okay, I remember the solution. So now, right, I is going to start here. Move it over a tiny bit. Space. So I is here. So I and DP is here. Right? So DP of I, set to nums of I, that's going to become a 7. Easy enough. Easy enough to understand. So then, for J, we're going to do J in range. Let's start at I plus 1. We want to go to the length of nums minus 1. Right, so what is this J doing? So this J is basically backfilling. It's kind of hard to see now what this J is going to be doing, but it's basically backfilling. Kind of backfilling like all possible picks you could make. Because this is going to loop through, it's going to start 1 over from I. So right now it's, first move, first run through of these, first iteration. j is going to be outside of the array. But then after that, because it's I plus 1, after that it's just going to, if I is over here, j will start at 5, and then it'll go here, and then we'll move I again, but it'll be our range. So, whatever. So what do we want to do, right? That's a good question. That's a very good question. So let's go ahead and move I and j. So now I is here, right? I is here. This has become 233, which is a big number. In this case, j is here. So we want to set what dp of j is, right? And dp of j, oh man, I feel like my brain hurt. Let's just think about this. So sleepy. dp of j. Right, it's going to be the max of nums of I minus dp of j. I don't really. Alright, if we want dp of j to hold the max, right? So right now, what is that going to do? So the first value we're getting here is 233 minus 7, which is, what, 226? So do we want 226, or what's the other choice they could have made? Right, this is basically saying player 1 like looking at just this array. Because basically what this is doing, at like any DP problem, it's dividing the problem up into subproblems. So this is looking at just this array of this size, 233 and 7. So player 1 obviously wants 226 versus what if they picked. The other choice would be what if they picked 7. Because this is them picking 233, player 2 gets that. So what's the other selection they could make? Is it just dp of j? Let's see this. That doesn't really help. That was a j minus. That was a j minus dp of j minus 1. So what is that doing? So what is that doing? So that's selecting nums of j, 7. But there's nothing there. How does that work? looping through correctly. Yeah, I mean that. So like this one. Is that why we don't go to length nums minus 1? We just act like the array extends farther. So I mean this is taking nums of j, which is 7, minus, I mean that's out of bounds, so 0. So which one? The max, right, dp of j is going to get set to 226, right, because that's great. So let's just keep walking through and see if this example eventually makes sense. Right, so that's 226. Solid work so far. Right, now I and j move. Right, I is here, j starts here, I is here, j is here. Right. So dp of j becomes 5, or dp of I, sorry. And then now our j pointer starts at I plus 1. It goes all the way through nums. We're going to set dp of j to max at nums of I, 5, minus 233. Pretty small number. Negative 228. And then, or nums of j, 233, minus dp of j minus 1, so 226. J, 233, it's going to be another negative, minus dp of j minus 1, 226. So 4, 7, right? What's bigger? 7. 7 is bigger. So that's where we're setting our dpj to. Boom. Okay. Right. And so now we're going to iterate through again. So now j. Right, j has not fulfilled its requirement as specified by that for loop. Right, so j is now, and it's not going backwards, you know, like I. It's going forwards. So j is going to go here, here. So now we're going to reset this 226 value. So it's going to be nums of I, again, oh boy, 5, minus dp of j, 226. Did we just calculate that? No. So that's negative 221. Really little. Not a great call, right? Or it's going to be nums of j, 7, minus dp of j minus 1, which is off the map, so I think it's 0. I don't think I'm doing this right. Let's see if we can try to find the video I found. There's this guy, I think. Yeah. Let's see. So I'm doing something wrong. Because he's never... How is he getting that j minus 1? It's not clicking for me. How is that j minus 1? That's not... Oh, it's minus 1. Oh, okay. It just clicked. Sorry, guys. So yeah, this is incorrect. It's 7. Right, because it's j minus 1. Fuck. Um, it's not j plus 1, so it's not going to go out of range. It's going to go back. So frustrating. So I guess we just gotta step these back one. Not a huge deal. It's not too bad. So we're back here, right? I and J. So DFUI times I is equal to 232. And then we can shift to the next iteration. Okay, boom. J goes here. There's that J. Getting better at drawing. Not that much better. Oh, it's hard. So yeah, now we're here. dp of I equals nums of I, setting I to dp of 5. Okay. Now we have our j. We are looking at what should dp of j be. It's the max of nums of I, 5, minus dp of j, 233. Really small number. 228. Bad number. Or nums of j, 233 minus dp of j minus 1 minus 5. Seems like a much better option. So this is going to become 228 versus negative 228, right? And that's where the difference in selection comes in. Because basically what we're tracking, right, is the max difference between the two player scores, right? Loop through it, and then now dp of j gets moved, or our j pointer gets moved in both. I wonder if I could just move these. Are the only ones? Alright, whatever. Go back to just deleting these. J, okay. dp of j, 226. We're going to find a new 226. Oh boy. Right, we're looking for the max between nums of I, 5, still 5, dp of j, which is 226. Sorry, I deleted it a little too soon. Small number, negative 221. Not a good number. Very little. Or nums of j minus nums of j is 7. Well, we might be in a pickle here. Minus dp of j minus 1, 228. So either way, we're getting negative 221 here. It's not looking good, right? Iterate through again. Nice here. There's 1. J starts here. J starts here. Okay. So now dp of j, the 5, is going to be the max of 1 minus 5, negative 4, or it'll be nums of j, 5 minus 1. So this becomes 4. Nice. J gets moved to here, J gets moved to here. And then we say, okay, 228, you've been great. Let's see if we can find something better. So, nums of I, 1 minus 228, small number. Nums of j, 233 minus 4. I think I'll take that. It's actually a little bit better, 229. Right? And then j gets moved again to here. Oh boy, oh boy. And then, sorry. Right, dp of j is going to be the max of nums of I, 1, still at 1, minus dp of j, so negative 221. So that's a positive number. That's actually positive 222 because we're subtracting a minus or a negative number. Or nums of j, 7 minus 229. Not a good number, but we still got one big number plus 222. So that's the max difference that can be found. And if we just go through this with our brains, right, and playing optimally, player 1 would first want to select the 1, so their total is 1. Player 2 then selects 7. So we can keep track here. 1, 7. Player 1 then selects 233. So they're at, what, 234 total. Then player 2 would select 5, it's the only thing left. So 7 plus 5 is 12. 234 minus 12 equals 222. So now we just want to return dp of the last thing in dp. If it's greater than 0, we just want to return true. Or they can also tie. I think you gotta do it the other way. Okay, no. Yeah. Okay. I'm actually pretty happy with how well I remembered how to do that. Yeah, cool. So the runtime here is going to be O of n squared, right? Because we're looping through nums, our list, twice. And the extra memory is O of n because we're creating a DP array. Yeah. Awesome. Nice. Man. Okay. I feel like I understand that problem better now, too. DP is just so tricky, man. It's hard. Let me make sure. So I can keep track. Go ahead and say we're good to go on that problem. I was doing this because, like I said, I thought I was going to interview with Cisco. I hopefully still will. But I was doing this because I tried to look up all the Cisco problems, create a little list of them. I was like, okay, I'll just get good at these problems and hope I was asked one of these problems. But then now I'm like, I feel like that'll hamper my growth long term, which is right. That's more important. Like, yeah, it'd be great if I can get a job now. Starting Stone Game. Stone Game is pretty tricky as well. Shout out to NeetCode. Dude, that guy's amazing. Show some notes. Yeah, but NeetCode is a beast. So nice. He's putting all those videos out. Right. But yeah, I was trying to get good at Justice Cisco problem. It showed me to definitely not hurt me, but I might, I've had an interview for another company. In the meantime, while I'm still waiting to hear back from Cisco, so I'm like, well, probably should just stick to the original plan, get good at LeetCode in general. Yeah, instead of just focusing on one company. Yeah, so here we go. 877 Stone Game. Ooh, another DP problem. Like I said, watched the NeetCode video on this, and he used a recursive memoization cache solution where he's basically doing BFS. I think he is doing BFS, isn't he? Look at my notebooks. I think he is doing BFS, if I remember correctly. Or, BFS isn't recursive, so no. It's not BFS. Yeah, I don't think it is BFS. He uses recursive top-down DP. Yeah. Okay. Alright, let's give this a shot. Right, so 877 Stone Game. Alice and Bob play a game with piles of stones. There are an even number of piles arranged in a row, and each pile has a positive number of stones, piles of I. The game is over with the most stones. The total number of stones across all the piles is odd, so there are no ties. Alice and Bob take turns, with Alice starting first. Each turn, a player takes the entire pile of stones either from the beginning or from the end of the row. This continues until there are no more piles left, which person with the most piles of stones wins. Turn true if Alice wins the game, or false if Bob wins. I wonder if the solution to the last problem could be used. Wait. Just copy this in. Should change the files. There's actually a really good solution to this problem. I'll show it in a second. Oh shoot. Not going to do that. I don't know if that works. Yeah, it should. That's so funny. Interesting. Okay. So yeah, I mean you can use that same because it's another game problem. It's a super similar idea. It's basically the same idea, except this. This is the only difference. You're gonna even number of piles, as well as the fact that if they tie, then it's false. That's the only other thing. I think. No, it must not be. Oh, it's odd. There's an odd number. Yeah, here we go. Yeah. So if they tie, it's false, but they can never tie. So, or I mean, you don't know if it's false or true, but there's never a tie. So what you can do is you can just say return true, and boom. Done. And why that works is because there's an even number, and we're guaranteed that it's not an even number. There's an even number of indice values, and we're guaranteed that it's not an even number. These add up to. The sum is not even. Alice can always win because she gets to pick first. Right, so I could start going through, like let's just go through this one. So Alice can pick the 3, right? Bob picks the 3, both have 3. Alice picks a 7, 10, Bob picks a 2, 5, you lose. Here, Alice picks the 5, or I should probably want to pick this 5. Alice picks a 5, Bob picks a 5, they both have 5, pretty good start for Bob. Alice picks a 4, 9, Bob picks a 5, 8. So, no matter, you can go through a bunch of different things, but Alice is always going to win. That's actually really cool. So this solution is basically the bottom or top down recursive DP with cation memoization solution to this problem, and this is basically the bottom up solution to this problem. That's actually so cool. Okay. Let's try to code it up. So, recursively, what's the concept? So, right, we got our piles. What's the concept? Right, we got our piles. Right, recursively. Concept is what's the max of these two? Right, what's going to max your total? Right. Yeah. That's kind of the idea. Right. Bless you. Bless you, bro.
Do you hear me?
Yeah.
Sorry.
Nah, dude. I think I hear you pissing earlier.
What?
I hear you pissing earlier as well. Yeah, it doesn't matter. It's fine. Like, let's see. So what's the base case? Base case is if like we run out, right? Let's see. We just want the two. Okay. Just give me an idea for kind of what guide to make. So what do we want to do? I'm not gonna lie, I'm blanking really hard on this one. Recursive DP with cache. Try size of array. So actually, I wish we had visited. Totally blanking on this. I'm not gonna lie. So he is doing depth first search. Yeah, don't just cut it out. You can do this. We're passing left and right. So we have our DP cache. Passing left and right pointers to that. Right. Might need to do an easy problem after this. This is hurting my brain too much. Left. I mean, don't we want to set left to the beginning of it? I'm just so confused. Can't wrap my head around this. So we have to do our base cases. Yeah, I'm just gonna copy. Didn't work. Right. Okay. Let's take a look at this. So our base case is if the left pointer goes over the right. So basically we're setting left to be here. Even equals true. I mean, but where are we setting left and right? That's what confused me. Are they just the piles? Mm. If left is greater than right. Well, that's obviously a base case. And then if left to right, if that combo is an RDP, right? So we're storing our DP. It's like a dictionary. Where, right, the key is this left, right pointer combo. And the value is Alice's score, I assume. Right, Alice's total. Left goes as L. I mean, would it work if we say oh geez, that just crushes the runtime stuff. That's so interesting. I don't know what I just did. What? Oh. Oh, interesting. Oh, it does it. But this solution is just much faster. Oh, that's interesting. I think, yeah, because Lico doesn't like recursive solutions. So if left is greater than right, then we're keeping track of whose turn it is, right? Because if there's an even number of piles, because it starts even, it's Alice's turn. When Alice takes a pile, it's going to be an odd number of piles left. So it's Bob's turn, and then Bob takes a pile, it goes back to even, so it's Alice's turn. So we're setting left to be whatever the value of our left pointer to be, if even, else it's at 0. So I have a question. I have a question for you.
Yeah, whatever.
So look at this. This is a top-down DP solution.
Mm.
Right, where we're recursively, it's like DFS recursive with caching.
Okay.
Yeah. But I'm just curious, so we're using like left and right as like indices in the array.
Right.
But where are we setting? We're not setting left and right to start at anything. What's it going to start left and right at?
Well, I mean, 0 and then like length of pile is -1, right? Like the two ends.
Yeah, I mean, but we just don't do that. It runs fine.
What do you mean? You're doing it.
Okay. Fuck.
Oh, yeah. Is that like somebody else's solution?
Yeah. This is neat code. It's so interesting, dude. Look at this though. Fucking. So there's this problem. 486. Predict the winner.
Mm.
And I'd like found the bottom up solution.
Right.
1D DP bottom up. And then this solution found the recursive DP with caching.
Yeah.
But there's really similar problems. So the solution to this problem can just be implemented to solve this
That's
problem.
true. Yeah, I mean,
And
that's
then this
the whole
problem, so it's just like
thing.
1D DP. It's like the bottom up version of solving that problem, and then the top down recursive DP.
Call you bottom up.
Yeah, for real. Okay. This is going on kid friendly YouTube, bro.
Oh, really?
Okay, so here's where it makes sense. So yeah, here's where we're making our call. Where we're setting left, right? DFS left is 0, right is like, so we don't need to set them up here. Yeah, sorry that confused me so much. And we just want to return if we start, our left and right pointers out here, and we, whatever max sum we get. If it's greater than, just summing the entire piles divided by 2. Because that means else 1. So yeah. Man, I'll leave that at no. I didn't do that one. I don't really feel like doing any of these, so I might just do another easy, but one I haven't seen. So got about another 25 minutes I want to go. Boom. Alright, so this is like, okay, so 557, first words in string 3. So we're given a string S, and we want to reverse the order of characters in each word. Given a string S, reverse the order of characters in each word within a sentence must have one space. And initial word order. Nice. Yes. Well, that's such a weird word they have there, for example, too. Godding. Godding. God damn. Okay. Let's think. I mean, I'm sure you could do like something like this. Oh, versus a list. Okay. Well, that doesn't work. So we're doing a string reverse order of characters each word. So we want to do it like this for. Okay, so these are some good hints. S does not contain any leading or trailing spaces. All the words are in S are separated by a single space. So split, call it split S, and we can do S dot split string, is it called? Let's see the results. W3 schools. Show me the results. There we go. Okay, so we'll just give this each list is. Alright, so let's do that. S dot, what was it called? Split. S dot split. So basically, this is going to split S into a list of lists. Be a little bit easier to work with. So do you want to do that? It's just going to give us like God. Such a weird thing. Alright, so now we have a list of lists. So now we could use a reverse method. So for word in split S, what does that do? Let's see what that does. Just return word. Return something. So you can't do reverse. Okay, so we'll have to do it kind of the hard way, or harder way. So we want to loop through each word. So these are the words. 0, 1 word. Then for letter, in word. We just have a temp. Temp equals letter. Word dot. So we're here with our L letter. We have our temp. We set temp to be G. Should we delete? Like if we use that temp to store the current letter we're at, we would need that. So if we append God, so now we got God G. No, we don't want to do that. What if we looked at it backwards? Right, we start here at D, and we just create a name. And we don't try to do this in. We don't try to do it in its place, you know. Yeah, like that. Go backwards through this. Well, we don't need to go backwards through the words. Okay, I like that. So now, letters here. All right. So D. We just have our answer. This is not an optimal solution. For sure. That's what I was breaking me. Then we just answer that append letter. Should be able to return answer then, right? Because it's gonna do here. I think something's wrong here. Yeah. Oh, that'd be good. Oh, we want answer to be a string. Sorry. How do you do that? How to? How we can concatenate strings? Should you just add it? Just like that. I think I've never done this before. add. Pen. I don't want to look at solutions. It's cheating. Answer plus word. What the heck? It's the same. So he's doing it in place. So this should, is that gonna work? I just need a plus equal. Yeah, so that's working. Cool. We just need to find where to add spaces. He's got a funky check here. Yeah, so if can we just do it like this? If our letter equals 0, we got a space. No. Oh, but then we'll add a space at the end. Return answer minus a space. goes his face. What? Can't do minus. If word of that's not gonna work. Can you do if is? No. EH. Why is it doing? Well, let me send you that. Why is it doing that? If word a letter. I mean, it's a better check, yeah. double check here actually. What? Forge is not even. Better. What? Oh man, defeated. Damn, bro. Concept is mostly there. I'm so tired. Yeah, I mean the problem with this test case is there are no spaces. It conveys. Just like if defense rating equals else. It's slow. Oh jeez. Yeah, I like it too. So we're splitting. He's doing some strange concatenation stuff. String slicing. Never seen that. So you string slicing. Interesting. I've never seen that before. Let's see. So I mean, you can do slice, start, stop. Oh, here we go. start, stop, step, start, start. We can be there for some reason. To stop, and then here. Dang, and then what is that double? What? So Prince string in reverse. Reverse. Is that? Does that do anything? Oh. Oh, you're just saying. Oh, that's so interesting. I get it now. So. Oh my god. I get it now. This is some kind of fancy stuff, though. Going through list to list. So lists. Yeah, man, this is some kind of tricky stuff, man. So, how this works. Let's just see if this how fast this is. We're going just through I, and then we're adding the stuff in I in reverse to answer. And then if I does not equal the length of words, minus 1. And add it. I don't really understand that condition still, how that works. There's time complexity in these. It's faster. Doesn't take up more space, but it's faster. Interesting. I don't know why. What is this condition? Length of words. Okay, well, I don't know. Still thinking, but I appreciate it. See you guys.